So you see some demo program for move function. So in this, as usual, we added all the modules in the project as in actual physical PLC controller. So after that, you click this and write the program. So if you want, you can change the program name also. You can rename as move some demo. So you can have your own program name. So after you double click, this program window will come. So now just you will see how to move data from one location to other location. So we'll give some start inputs. So ladder elements, just to click here, we're given some start input. So once start input is given, we add the move function is actually available in this function block. Okay, it is in other operators it is available. Just move this here. So in that we have some value coming from some other analog input. Okay, so we have some analog data is coming, so that so analog, so that the data, it is integer data, so we want to move to the timer. So timer also, we have some counter data or counter. We have some data coming from some sensor. Okay, so it's a unlock sensor, so that we want to move to the counter. So thing is, for timer and counter, we cannot move the integer data. We need to convert this timer data into time. So it is an integer, so this also integer. So this one will be using some conversion block, which will convert the conversion. We need to make this as integer to time conversion. Integer to, this should be a time. So it's a time conversion. So here we need to give this timer value as integer. This one will give us a time set value. This will be converted as a time set value. Okay. So now we'll start the timer. So we'll have some input. So ladder elements, you can have some input for time start, timer start. So then we'll add some, okay, then we'll add some timer here. So this timer we can have T1. Okay, so T1 preset value, it is the time value, right? It is actually coming from some analog data. So this is time set. Okay, then here time whatever running you can see by giving this. So now what I do, I will use another move block. So in that move block, just I will give the data to as sample 4 1 5 6 7 8. So 8 ones were given to percentage of QP0. QP0 means it is a byte. Byte means 8 bits. The output 8 bits will be filled with this all 1111. That is, in a PLC, the first model, all outputs will go on when you give like this. So when the timer on, so it goes, it will fill this. Okay. So instead of timer, we can give the count input also. For example, just we can modify program and function block. We'll add some up counter here. Okay, so counter reset, we can give some reset input, set underscore 1. Okay, so preset value, when we give 2 times. Okay, here the preset value, we can take this counter value. Okay, and it will take, so the preset value, it need to be word, it is given here. Actually integer we need to convert as a word. Okay, so for that we need to take conversion again, need to put it here and convert this integer into word. Integer into word data. So this will be counter, so we'll convert in the count inputs. So we'll convert this one account input. So better we'll add one run below. Okay. So this counter, so this counter just will trap and put it here. So this will be count underscore input. So here we will be giving count input. Okay, this will be count input. So this count input will be given here. So this need to be a contact. So this will be count in, okay, so this will be, so some take us some sensor, digital sensor, so it just counts. Okay, here this should be count input. Okay, so now we'll so in the third run, so instead of this, so you can have our counter. So better we can change, this is C1 for simplicity purpose. Okay, we can have it C1. So this input, so the C1 dot Q. So the whole program is like this. And the start input is given, this analog data will go here, timer, sensor data will go here, counter, these all analog devices. So because this one cannot be directly given to counter preset value and timer set value, we are just need to convert integer into time. This integer value will convert into time. Similarly, the sensor value in that integer need to be converted into var, so that can be given as a preset value here. This value need to be given as a preset value here. So when the sensor here sensors counts to value, so the counter will on. So counter output will be given here. That will enable the timer. So timer set value already it will coming from the this analog data. So timer runs, and timer reaches the preset value, then this move will move all these 111 to the output. So output model, all the output will go on. You just log in. So before that we need to check the IP address. So it is 18, okay, it is communicating properly, okay. Then we will we need to log in. So we'll log in and see any error is there. Okay, so they given the compilation error. So they given one error in network 2. Okay, expression, okay. So if any error comes, we need to troubleshoot that. So I will just log out. So network 2, see this value they given us error. So I'll give some count value. So whatever count we can see here. So this is how we can troubleshoot any error in the program. So login, login, login. Now it's okay. Now program it's okay. I see this analog values are not given. First you give that start input. So debug. You can give right values. Now this analog input we need to give the value. For example, if I need 10 seconds, I get to give 10,000. So it is taken as a millisecond. Okay. So it is 10,000. Then you have to give debug right values. See it is 10,000 and say timer it takes 10 seconds. Okay. Now counter value it is not set. So already it is so output is already on because counter value because not set it is 0 0. It closes this and it takes 10 seconds counts and we got output here. So we'll do one thing, we'll stop this debug right values. Just we'll give the count value also. We'll give the count value of 3. Okay, and debug right values. So now time value is given 10,003. Okay, so this all data will go here. We'll see. So now we'll start debug right values. So now see preset value counter becomes 3. So timer it is not on. So we are having here 10 seconds. Whatever 10 seconds given it comes here. Whatever counter value moved it comes here. So now this sensor we just enable right values 1. Then switch off. Then right values. Right values. So next time when I write, now timer starts. Debug right values. So 3 comes. Now see timer starts. When timer here reaches the preset value of 10 seconds, now this all data will move to the output byte. So all the 8 outputs were goes on. You can see here it becomes 255. 255 means all the bits of output goes on. So this is how for different cases we will be using this move functions. So if I reset this, so now counter goes off. Right value, timer and counter goes off, everything will go out. Okay.